Properties of exponents, as you can see, it's not really an Algebra 2 SOL. Something that supposedly you've already learned before. But every time we get to this stuff in Algebra 2, it's clear that we need a refresher on it because we make a lot of mistakes with it. So that's why we take a day. And in this textbook, it's actually the first section in chapter 5. In the old textbooks that I dealt with, it was actually not its own section. It was like just some of them called Algebra 1 Review. It was like a separate thing, but it was not an official section in the book. But this one is. So, these are the properties of exponents. Right? There's 7 of them. Now, you don't have to copy everything. Obviously, it came from the book. You can get it. I mean, you're welcome to if you want. Just like I showed on the homework, right? 10 to the negative third times 10 to the negative 5. You add the exponents. That's the first property right there, right? You're multiplying, right? Something raised to a power, and the something, the a, is the base. If the base is the same, then you can simplify it by writing the base and then add the exponents, which there's an example of it to the right. 5 to the third times 5 to the negative 1, right? It's got to be that the base is 5 on both. They have to be the same. And then you just add the exponents. Now, I usually don't think of them necessarily in this order, because once I think of that one where multiplying means you add, then I would jump down to quotient, right? Quotient means divide. So when you divide a to the m divided by a to the n, what do you do with the exponents? Subtract. So the first one is to add, the second one, this one is the subtract. The one that we might get confused, the first one with, is these first two. It's when do you add the exponents? When do you multiply the exponents? Right? When you raise a power to a power, that's when you multiply. They call that the power of a power. 3 to the third in parentheses squared is 3 to the 3 times 2. That's the multiply situation. And then another two that I would associate together are when you have parentheses and a power outside parentheses. Inside the parentheses here, it's a product, A times B. So it's not really distributive property, but if you want to think of it like it's distributed, it is, right? I mean, AB to the m distribute the exponent onto both factors, A to the m, B to the m. Or if what's inside the parentheses is a quotient, A over B, then you can distribute, right? A to the m divided by B to the m. That's 5 of the 7. The last two are, if you have a negative exponent, then most of the time the problems will say, don't leave negative exponents. If you've got a negative exponent, you need to do something to get rid of it. And the something is, you flip it to the other side of a fraction. A to the negative m equals 1 divided by a to the positive m. Or, they don't show it right there, but there's their example. 7 to the negative 2 is 1 over 7 squared. But what if it was 1 over 7 to the negative 2? Well, then again, to get rid of the negative exponent, you would flip it to the numerator, and it would become 7 to the positive 2. And that leaves the last one, which is a to the 0 equals 1. where a does not equal 0. Basically, anything raised to the 0 power equals 1. And we can make sense of that if we think of this, the quotient of powers. I mean, what would I get if I had, I'm going to try to slip it in here, or I'll do it at the bottom here. What if I have a to the third divided by a to the third? Well, that by the quotient, that's a to the 3 minus 3, which is a to the 0. But what is anything divided by itself? 1, right? So that's why anything to the 0 equals 1, right? Not a to the 1, it's the number 1. So those are all the properties. A lot of times when they get a problem that has something to do with the 0 exponent, you know, the number inside is a little on the ridiculous side because they're trying to make the point. You know, don't try to calculate this out. You know, it can say, you know, in parentheses, my refrigerator in parentheses to the 0 power. You're still going to say 1. Anything to the 0 power is 1, as long as it's not 0. So negative 89, I mean, it's kind of a, it's not, it could be weirder, but it's not a normal kind of example that we would deal with. But these are the 7 properties of exponents. Now, there's going to be 2 kinds of examples that they do here. The first set of examples are all using expressions of numbers to use the properties of exponents. There's no variables here. And then the next set of examples, there will be variables. There'll be variables, there'll be numbers and variables, and we use them. But these here are not. These are just numbers. And they are making a point of every line that they do something, they're telling you which property that they used, right, out of these here. When you do them, you need to simplify them. You don't need to necessarily show, you know, what property was that you used. And there's more than one right answer to which properties that you use. We'll see that along the way. I mean, if I was going to do this thing here, if I was just really told simplify this without regard to properties of exponents, I'd probably go 2 to the 5th is 32, negative 4 times 32, right? Negative 128, done. Or negative 128, and then I'd have to square it. But since the point of this is to use the properties of exponents, notice what they did from the left side to the right side. You know, which one of these did they use? Right? They had inside parentheses, they had more than one factor. So they distributed the exponent to each factor. Negative 4 squared, 2 to the 5th squared. Okay, now 2 to the 5th squared, that's raising a power to a power. That's this one. So that's 2 to the 5 times 2, which is 2 to the 10th. Now these numbers, you know, without calculators, sometimes they get a little challenging to figure out, but 2 to the 10th times 2 to the 10th, how could you calculate that? I tell you what I did. I mean, this is actually using properties of exponents. To me, I would say 2 to the 10th is 2 to the 5th times 2 to the 5th. And I know 2 to the 5th is 32. So it's not that hard to do a quick, you know, 32 times 32. And then you could do the times of 16. So that's their example. We'll get some U tries stuck in here too. So here's another one. Use properties of exponents to simplify this thing. So what did they do? What does it look like they did from here to here? What moved? What changed? What's that? They took it, you know, it was all raised to a negative exponent. So again, to get rid of a negative exponent, you flip to the other side of the fraction. So essentially, it's just saying flip what's inside, right? And that's what they did. The 11 to the 5th went to the denominator. The 11 to the 8th went to the numerator. That's what raising to a negative 1 does. It just flips everything. Okay, now you've got a quotient property. 11 to the 8th over 11 to the 5th, that would tell you to subtract 8 minus 5. And 11 to the 3rd, 11 times 11 times 11. Now, do you have to do it that way? What if instead of that, what if you use the quotient property first, like go straight down, and we would have 11 to the 5 minus 8, which is negative 3, to the negative 1. I mean, that's using properties of exponents. And then which property would I use? 11 to the negative 3rd to the negative 1, power of a power, multiply. Yeah. Well, whatever is in there, you would flip the numbers to. Okay. And what she's saying is, what if these weren't the same numbers? Still raising to the negative exponent would definitely flip the whole thing to the other side of the fraction. Now, would you be able to do this simplification if they weren't the same numbers? No, that part you wouldn't be able to do. But if I use this property here, there, I'm going to 11 to the negative 3 times negative 1 is 11 to the 3rd anyways. Maybe there's more than one way to do any of these things. And when you get to simplify, some of you will go this way and some of you go that way, and I'll try to follow it all. So try this one. To include doing the math, because what else do we got to do? Property did we use? The power of a power. We're raising a power to a power, which means multiply, right? That is 4 to the 2 times 3, which is 4 to the 6th. Now what does that equal? I mean, if you take it down this way, right, and say, okay, that means it's 16 times 16 times 16. Well, the 16 times 16 is 256. And then if I do that one more time, I think that's 4096. Okay, try that one. So what property do you have to start with here? Say again? Product of powers, the first one. How many of you tried to multiply negative 8 times negative 8 here? Right, that's not the right way to go, right? You can't multiply this negative 8 times that negative 8, right? Because that negative 8 is being raised to the third power. That one is not. So don't jump on something like that. What you can do is say this negative 8 is raised to the first power. That one's raised to the third power. Add the exponents. That's the way you want to go. So this is to the first. So this is negative 8 to the 1 plus 3, which is negative 8 to the 4th. And now will negative 8 to the 4th be positive or negative? Positive, right? Because a negative number raised to an even power should be positive. And now, in the way I look at it is this is going to be like 8 squared squared. That's 64 times 64, which is kind of the math we just did on the last set, 4,096. And you could do it. You could go 64 times 64, see what you get. That it'll be 4,096. And it's plus. One more you try. So which property do we use? The power of a quotient, right? So what does it look like when I apply the power of a quotient? 2 to the third over 9 to the third, which is 2 to the third is 8, 9 to the third is 729. 9 times 9 is 81, 81 times 9, 729. Okay. So these now are examples where we're using variable expressions, not just numbers. Sometimes there's numbers, but not always, right? So, and now we've got 3 factors, b to the negative 4, b to the 6th, b to the 7th. Which property would we use? You know, you can do more than 2, just product of powers means as long as the base is the same, add the exponents. I don't really have much to add to that. Negative 4 plus 6 plus 7. Maybe a little more here. So first, they used the power of a quotient to distribute the negative 3 onto the numerator and the denominator. Then they used the power of a power, r to the negative 2 to the negative 3, multiply to get 6. S to the third to the negative third is s to the negative 9th. And then because we don't leave negative exponents, it was flipped to the numerator. So now it's s to the positive 9th in the numerator. Remember when you're doing that, whether you're flipping something to the denominator or to the numerator, that it's only the one thing that has that negative exponent that's being flipped. Don't try to flip anything else as long the r doesn't flip because you're flipping the s to the negative 9 in the numerator, right? You're only flipping that one thing right there. I think there's another example. And there's our next example. Right. Sometimes, it's probably just a silly mistake when it's made, but it's made. You're doing all this stuff with adding and subtracting of exponents, and then you get to the 16 divided by 2, and you simplify it to 14. But that's what you're doing with the exponents, not with the numbers, right? You still treat the numbers just as numbers. 16 over 2 is 8. And, the m to the 4th, they didn't have anything to combine it with. That just stayed as m to the 4th. And then the property here, is since that's a divide, they subtracted. But then they got a 0 exponent, and anything to the 0 equals 1. And you don't even show it. I mean, there's no point showing a multiply by 1. Now, if I was really simplifying something like that, I probably wouldn't even use properties of exponents. I would just say, if I've got a common factor in the numerator and denominator, cancel them. I mean, I don't need to do that with properties of exponents. I would just cancel them. So there's your first few try. So how did that simplify? How many x's were left? Negative 6 plus 5 plus 3. It's x squared, right? And sometimes when we show properties of exponents, I mean, multiplying x to the 5th times x to the 3rd, we might write out and say, well, x to the 5th means x times itself 5 times. And then x to the 3rd is another 3 times. And so how many x's are there? It's 8. I mean, that's why the adding of exponents works. But what do you do with an x to the negative 6? I mean, that just means you're dividing by x times itself 6 times. X once, twice, 3 times, 4 times, 5 times, 6 times. And so now cancel, 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 and your answer is x squared. Next. Try that one. Okay, let me start by just saying there's the 7. Right? There are no other 7s to combine it with, no other numbers to do arithmetic with. Then what about the y's? Which property do we use to consolidate the y's? The product of powers, right? So we have y squared times y to the negative 4th. What do you do with the exponents? You add them. And how many y's is that? Negative 2, right? So that's y to the negative 2. Okay, how about z to the 5th times z to the negative 1? Another product of powers, so you add them up. 5 plus negative 1. Would you say that, Nathan? C to the 4th. Okay, but you can't leave it with a negative exponent, so what do we do to resolve that? What's that? So y, yeah, make it 1 over y to the positive 2. That will get rid of the negative exponent, but just don't do it with the 7. The 7 doesn't have that negative exponent. More than one person did that when I was walking around there. Right, the 7 stays where it's at. Try it again. So which was first property? The power of a quotient, right? Because we've got a power outside of parentheses and a quotient inside. We need to distribute that to the numerator, s to the 3rd squared divided by t to the negative 4 squared. And then what is the operation between the 3 and the 2 and the 4, negative 4 and the 2? It's a multiplication. When you raise a power to a power, you multiply. S to the 6th. T to the negative 8. But we don't leave a negative exponent. How do I get rid of the negative 8? I flip it to the numerator. Just the t, not the s doesn't move. S to the 6th, t to the positive 8. I think there's one more. Last one. So which property of exponents did you do first? The power of a quotient? Did anybody do anything different? I mean, what about, I mean, this is a property of exponents, so it would be fine to use. Why not instead, before you start distributing that to the 3rd power inside, what's x to the 4th over x to the 3rd? It's x to the 1st, right? And then y to the negative 2 over y to the 6th. It's y to the negative 8, right? Which you could flip to the other side. And then when you distribute, it's a lot easier. I mean, you're going to get to the same place anyways. But I would probably prefer to do that. Right, if I do it the other way, it'll look like this. X to the 4th to the 3rd, y to the negative 2 to the 3rd, that x to the 3rd to the 3rd, and y to the 6th to the 3rd, which is x to the 12th, y to the negative 6th, divided by x to the 9th, and y to the 18th. Okay, then I'm going to use the same properties, right? What is x to the 12th over x to the 9th? That would be x to the 12 minus 9. And y to the negative 6 minus 18. So that's x to the 3rd, y to the negative 24. But we don't keep negative exponents, so I flip it. X to the third divided by y to the 24th. Most of the time, if you do a lot of these, let's say, and you're looking at the y to the negative 6 over y to the 18th, I mean, you can see that if you subtract, you're going to have a negative exponent in the numerator, and then you're going to have to flip it to the denominator. Most of the time, if you see that the highest power is in the denominator, then just subtract from there. 18 minus negative 6 and put it there, 24. And now you don't have to do another step of flipping it to the other side. That's more common. I think it's supposed to say 24, and it just the writing is really bad. Or maybe I just wrote it wrong. Let's try that again. 24. So here's our check the errors. What did they do wrong on the first one? Abdo. They divided the exponents. What should they have done? Yeah. What should the right-hand side have been? X to the 8th. And how about the second one? What did they do wrong? They multiplied instead of added, right? So it should have been X to the 8th. And in the last one, they added the exponents, but what else did they do? They multiplied the bases. Remember, the bases don't change. Right? What should this have said? Negative 3 to the 6th. Base don't change. Okay. And that is the whole thing. And that is the homework. So just work on that. You can be done with it. Remember, you could check, all these are odd numbers. You could check to see if you're on track. You know, the question will come up, because it did last block too. You don't have to say the name of the property you're using. Just use the right property.